In this lesson we're going to take a look at removable discontinuities. Now before you start this lesson you want to make sure that you're familiar with vertical asymptotes and how you find them, and if you're not, I would suggest you go take a look at my video on vertical asymptotes. But as long as you know what that is, you'll be able to handle this just fine. A removable discontinuity occurs when we set the denominator equal to 0 as if we were going to find the vertical asymptote, but then the number we get for x, or the value we get for x, also causes the numerator to be equal to 0. So if they're both equal to 0, instead of a vertical asymptote, it actually causes just a hole in the graph at that point, and it doesn't actually cause an asymptote, and we call that hole in the graph a removable discontinuity. Let's take a look at this example that I've put up here, and what we're going to do is we're going to set this up just like we were going to find a vertical asymptote. We're going to set the denominator x squared minus 7x plus 10 equal to 0, and we're going to solve that. And when we do that, of course, this is a quadratic equation, so we'll go ahead and factor this. And of course this factors into 5 and 2. 5 times 2 is 10, and then both are negative because 5 times 2 is 10, 5 plus 2 is 7, both negative, which means that x is equal to 5 and x is equal to 2. Now we would normally think that this would mean that 5 and 2 were both vertical asymptotes. X equals 5 would be a vertical line at 5. X equals 2 would be a vertical asymptote at 2. But if we go back to the original equation, 5 squared minus 4, we'll notice that 5 squared minus 4 is equal to 21. That's okay. But when we put 2 in, 2 squared minus 4, I'm just substituting into the numerator. That's 4 minus 4, that's equal to 0. So in this case, our numerator and our denominator are equal to 0 when x is equal to 2. Therefore, x equals 5 is a vertical asymptote, but x equals 2 is a removable discontinuity. Now, there's a pretty easy way to be able to decide which kind we're dealing with here, and that is if you factor both the numerator and denominator, then if they have a common factor, then the x that results from that factor in the denominator, that will be the removable discontinuity. Let me take a look at another example here and I'll show you what I mean. I'm going to go ahead and factor both the numerator and denominator here. So the numerator first. So we have 12 here. So this should be 4 and 3. Both are positive. And then I'm going to go right ahead and factor the denominator as usual. This is what I would set equal to 0. This time we have 3 and 2. 3 is positive, 2 is negative. And you'll notice that I have an x plus 3 and an x plus 3, both the numerator and denominator, which tells me that the x equals negative 3 that results from setting the denominator equal to 0 is a removable discontinuity rather than a vertical asymptote. And the x that results from the x minus 2, which is 2, this is a vertical asymptote. So if we were to graph this, we would see that x equals 2 would be the vertical line that represented a vertical asymptote, whereas x equals negative 3 would just be a hole or a gap in the graph right at x equals negative 3. So removable discontinuities occur when both the numerator and denominator have the same factor. Let's try one right here. Again, this one even has a linear equation in the denominator, so I'm just going to factor out at the top the x. That leaves x minus 2. And at the bottom, I'm going to factor out a 3. which also leaves x minus 2. So what you notice here is that the resulting value x equals 2, since there is an x minus 2 in both the numerator and denominator, the result here of x equals 2 is a removable discontinuity, and this particular equation doesn't have a vertical asymptote. It only has the removable discontinuity at 2. One more right here. Sometimes we get so involved with removable discontinuities we forget that some don't have them. In fact, many don't have them. If I factor this top one right here, this factors into x plus 1 and x minus 2. And then the bottom factors into x minus 1 and x minus 4. Notice that my resulting solutions of x equals 1 and x equals 4, in these two solutions, both of them are going to be vertical asymptotes, because this time there is no x minus 1 in the numerator and there is no x minus 4 in the numerator, so we only use those two denominators with that set equal to 0. Those two solutions are both vertical asymptotes, and so in this case we don't have a removable discontinuity. So to find removable discontinuities, in summary, you set it up just like you would to find a vertical asymptote, but you go ahead and factor both the numerator and denominators, and then if your solution that you get in the denominator for x is a number that its factor matches the factor on top, that one is a removable discontinuity. If the solution you get on the bottom results from a factor that doesn't have the same factor on top, that solution is a vertical asymptote. If you need to see other topics, I invite you to go to my website at MyMathEducation.com or my Math Education YouTube channel. We have other topics there and we invite you to watch. Thanks for watching this video. If you enjoyed it, I hope you'll subscribe to my channel and come back and see other videos to give you help with your algebra. Thanks.